Have you been wondering how to take off staircase works? How to measure the volume of concrete, how to measure the length of the reinforcements, and also to find the areas of the formwork or the length in linear meters? Today's video will be able to focus on taking off staircase works. Welcome to our YouTube channel. My name is Naomi and this is the EasyQS channel. In this channel, we help students revise for their exams and also to grab concepts that could have bypassed them in class, especially in the quantity surveying and civil engineering units. Welcome so much. If you want to be our member, these membership packages, you can check them in the description box, and also you can subscribe and also hit the notification bell so that whenever we post new videos you can be notified. We have done previous videos on staircase works, and several students asked me to do it on the board to show clearly what we mean by measuring a staircase very clearly. So I'll be a bit slow in this video so that you can be able to understand and so that you can be able to measure all the works in a staircase. Welcome so much, and in case you will have any questions, just write them in the comment section. I'll be able to look at them so that I can know areas that you could not have understood. Also, if you like this video, you could remember to maybe let us know in the comment section, and also to give this video a thumbs up, and we shall appreciate. So we shall get to this video, and in taking off staircase works. A staircase is one part of a building which is made of reinforcements and concrete. It involves reinforcement, concrete, which are held in position, then they will form the staircase. They help in the movement of people from one floor to another of a building. When we are doing concreting works, now that we are using reinforcement and concrete, both so that they can be able to merge very well, we need to support them using maybe timber, maybe steel, and this one is what we call the formwork. The formwork is that temporary structure that we put in place so that whenever we do concreting, before we can wait as we cure so that the concrete and the reinforcement can come into place. That formwork is the support system. So when we are taking off staircase works, we will always take off the formwork because we will have to buy the formwork, and also there will be labor needed to install it. So because there are cost implications for the formwork, we shall measure the formwork. Then we shall come to measuring the volume of the concrete. Concrete is made up of cement, sand, and ballast. So we shall measure the total volume of concrete that we shall use in the staircase. Also, we shall measure all the reinforcements that are needed in the staircase. And what will guide us in all these things is we shall use this plan and we shall use the section. When we are taking off the staircase works, we always first have to understand the drawing, just like any other building that we will be able to take off. We will always have to understand the drawings. So in this case, we have the plan and we have the section. Once you understand the plan and the section, you can be able to take off. So never begin taking off unless you have understood the drawings. We are doing several videos teaching you how to understand drawings. I realize that some of you may not be aware of these things, so we are constantly doing these videos for you so that you can be able to understand all architectural and structural drawings so that you can be quite good in taking off. So in today's video, I'll be able to take you through understanding the staircase and how to measure it. We have done already about measuring, and we shall also do it on the board. But right now, what I want you to do is to understand the parts of this staircase and how they are measured. Then we shall do a next video showing practically how we measure each of them. So stay tuned. Okay, so when we are taking off, we have said the first thing is understanding the drawings. Here we have the plan. Here we have the section. When you're given a plan, how will you know what it shows? First of all, when we come to the plan, this shaded part here shows the walls of the staircase. Then the staircase usually have steps. these are the steps, and they are shown by an arrow. That's here it's up, then we are going down the staircase. So this is if you are told here it's up, so when we are coming up the staircase, we will start from down here. Maybe the entrance is here because this is the opening we have from the walls. You will come, then you will come in, go up, then you go to this point. This one is called a landing. The area where, okay, a staircase is made up of a flight where you go up, then you land a flat area, then you go up again. Whenever you're going up a staircase, like in this case, we can start it here. Whenever we are going up a staircase, this part is called a flight. Then if this flat place that you find is called a landing. You land here. Then you take another flight up. Alright? So this is the ground floor, assuming this is the first floor. So we shall take, you shall begin here. You take the first flight, you land, then you go up the staircase. This one is the wall, as we have said. These ones are the number of steps. We said that in a plan usually shows the aerial view of something. When I say aerial view, it means the view from up there. Assuming you are flying up, passing a building, and you're in an aeroplane, then you looked down and saw a staircase. What would you see? You will not see this part of the staircase. You will be able to see this part of the staircase. What you see from up there, you'll be able to see these steps, but only the lines will be able to tell you that these parts are separated. Otherwise, it will look flat. No wonder in a plan, everything looks flat. But when you look at a section like section XX, we are told is like you're cutting the staircase from here, then up to here. Here it's section XX, we have cut the staircase. So we are looking at the staircase from the side. From the side, this is what we shall see. A section is when you look at it from the side. Then it has to be inside here so that you can see inside the walls, inside these steps, what is there. So that's why you can see even reinforcement bars. You can see concrete in the staircase. Alright, so a section usually shows the vertical view. The plan shows the aerial view from up there. So when you look at this section, these walls that you are able to see, this wall that was cut here is this wall. This wall that was cut, it is this wall. Then we cut even these steps. Where it was cut the steps, this is what you can see from this section. Alright? So, we said that a staircase is made of a flight, a landing, and a flight. What is in this flight? When you look at a staircase, I need you to look at it very keenly so that you can be able to see. In a flight, we usually have the steps. You see, these are the steps. Okay? So when you're walking up a staircase, you will see the steps. The steps will lead you to the landing. So, if we were to count the steps on this staircase, how many would they be? We would count the first step, 2, 3, 4, 5, 6, 7, 8, and here we have the 9th step that you will have to go up. Alright? So that once you're done with this step, now you'll walk into the landing. Then you'll start going up the second flight. So you'll come here and walk up the first step, second, 3, 4, 5, 6, 7, 8, 9. Then you'll go up the 10th step. Once you go down up the 10th step, once you get here, now you're in the landing. Alright? So we want to know, now that we have known this is a flight, and this is a landing, and this is the second flight, and that these are rails that are here, they are usually to support or to prevent things from falling off the staircase. People hold these rails sometimes when they are going up a staircase. As children, it prevents children from falling off the staircase, even if they walk at the ends. One thing we know about staircase is one end it goes to the wall, the other end is where we have these rails, right? So these rails are only on one side. The other side we usually have the wall. So when we are walking up a staircase, this side we have the wall, this side we have the rails. So whenever we start walking up again the staircase on the second flight, this side we have the rails, this side we still have the wall. Alright? So in a staircase, now we want to understand how are the reinforcement bars usually are. You see, for example, this bar, it comes this way, it runs this way, then it runs this way. Then it meets the bars that are on the landing. In the landing, the bars form a mesh. You should always visit a construction site, so that you can be able to see these things. One day we shall go and we shall be able to see how reinforcements are done in a staircase. So the reinforcement bars in the landing, they will form such a mesh. In the flight, they will also form this mesh. But these reinforcement bars that are running this way, they should be able to be tied together with those in the landing. And also there should be a bend on the reinforcement bars coming down here, so that it can be able to form a footing for the staircase here. Because here we usually form a footing to support this staircase. This staircase is only supported by the reinforcements that are here at the foot, the wall here, then it goes up and it is supported again. Otherwise the staircase is not supported by, you see, sometimes we do the structure of a house without having any walls. Do we have staircases? Yes, because the reinforcement bars that are assuming this is the first floor, this is the second floor, this weight of the staircase is supported by both floors. The reinforcement bars must come inside this floor, then they should come inside this floor. Then the staircase is supported by both floors. Alright? So, when we have this staircase, now we want to know how do we measure the formwork when we are doing this staircase. For example, so that we can be able to put the staircase in place, we will do formwork here, below here, so that it can carry all the concrete. Then we shall come placing formwork at every step, running like this. I hope you understand. At every step, this one we can see the edge of the step. We can see the steps, they are going like this. These steps are going all across here. This is one step, but its length is this length. This, assuming we are starting from down here. Okay, this is the first step. So its length is from here to here. This is the second step. Its length is from here to here. Alright? This is the third step, the height. But its length is from here to here. Those are some of the things that you need to see very clearly. So this is called a riser. This is called a trend. Here we are told a riser is 175 millimeters. A trend is 225. So this from here to here is 225. This riser is 175 millimeters high, but the length of that formwork that will support that step is from here to here, because once you're going up a staircase, this is the width for going up. You get to the landing, you come and go up again. This is the width. All right? So when we are doing formwork, there is that formwork that will support below the staircase, below the concrete. Here, below. Alright? This part is usually called the soffits. When you go under a staircase, you will be able to see these places that are below the concrete. We shall be able to go to a staircase, then we shall show you this part very well. This part below the staircase, under it, it's called the soffits of the staircase. The soffits. Then this is the landing. Below the landing, under it, this part, when you look up, that concrete, here it's called the soffits of the landing. Then once you're going up the staircase again on the second flight, this is the soffits of the flight, under it. All right? Then here we have the soffits of now this floor above, because it has come to that floor. Alright, so when we are doing we are calculating the area of the soffits. How shall we calculate it? We shall calculate the area of the soffits of the staircase by taking the length, you see, from here up to here. We shall find this length. Then, after we have found that length, we shall multiply by its width. The width is from here up to here. Alright? So, when we are finding the area of the soffit, we need to know the length of it times the width. Because area is equal to length times width. So, the length shall be this vertical, then the width shall be this width. Right? So, that is the area of the soffit of the first flight. The area of the soffit of the landing, we shall take the area from here, this flat area. You know, formwork has to be where it's flat. Formwork doesn't bend like this, at the same time it's flat. So the area of this area we shall calculate separately from the one that is bending. So from here up to here, we shall take this one as the width. Then we shall multiply it by, you see this is the landing from here up to here, because we cannot support formwork where we have the wall. If the wall will carry its own concrete. So we shall support using formwork where we don't have the wall. Then the length of the landing shall be, if we are going up like this will be the landing. We shall start the length from here up to here. You see, we are taking from here up to here. But it will not be up to here completely, because while we have this last step, the last step is at the landing. If you can see, the last step, it's not here. You see, this is a step. So the last step will be up to here. So the soffit will begin somewhere inside the landing on the section this way. So to calculate the width of the landing, it will be after you have looked at the width of this last step. So from here, you'll see here we are given the length from the edge of this the last step. This last step is on the landing. So from here up to here, it's 1200 plus 215. Okay, for the formwork, we will not consider the wall because we do not support concrete where we have the wall. So you can see from here up to here, it's 1200. But when we are doing formwork, we shall not take it from the edge here. You see, this edge here is this line that we have here. That's why I said you have to be very keen. This edge here is the one that we have here. If we take from here up to here 1200, we will be meaning that the formwork shall start from here. But we know the formwork will not start from here, it will start from here, because this one is a slope. So the area of the formwork for these steps will be calculated in the flight. But when we come to the landing here, we shall take 1200 from here up to here. We deduct the length of one strand. It's just that this last strand is on the landing. So we shall take like 1200, we deduct 225, the length of one strand. So that is a very important point to note. This last step is on the landing. So once we are calculating formwork, this formwork that we need to calculate the area, it can only be supported where it is flat. And where it is flat, you have to deduct this strand, because this strand will be supported by the formwork that is on the flight. We shall be able to see that practically when we get to the staircase. We go to this second flight. When we are calculating the area of the formwork with these steps, all right, we shall take we shall support this formwork from here. You see, it's the other side, this area up to here where it's straight. From here up to here, that is where we shall take the length of the flight. Then we shall multiply by the width, which is from here up to here. All right, this one is the slab of the second floor, of the floor that is If this was first floor, this is second floor. So this one, the staircase will come into the slab of the second floor. So this one we shall not account for it. What we account for in staircases is the flight, the landing, and the flight. When we get to this slab, this shall be measured in the concrete works for the slabs. Alright. So what we were talking about is the area of the formwork for the staircase. We will support the soffits. The soffits is the bottoms. Alright. So we have said for the flight we shall measure from here up to here. We multiply by the wind, which is from here to here. For the landing, we shall take from here up to here. We multiply by the length of the landing where we don't have the walls. Alright. Then for the second flight, we shall start from here up to here. Up to here. Then we shall multiply by the length of the landing of the flight, second flight. Alright. So that one is the formwork. When we come to the other formwork, you see we have already supported the bottoms. Now we need to support the sides so that concrete doesn't pour. So how do we calculate for the formwork to the sides? And what are these sides called? The sides are called the edges of the striggers. You see, we usually have a name like striggers. When we are calculating this formwork that is here at the edges, we usually call it the edges of the striggers. And we have said one end of the staircase is at the wall. The other end is the one that we usually have the rails. That end that we have the rails, we need to do formwork on that side. Alright, so that concrete doesn't pour. So how do we calculate for the area of that formwork? We will still take the length from, you see this one, we shall be supported from here up to here again. Then we shall multiply, we shall take this length up to here. That one is calculated in linear meters. From here up to here, that is the length. Then we shall take from here up to here. That is the length of the striggers. Alright? It is one side that we are supporting. Then for the landing, we will also need formwork. Let us use the plan to see where we shall need formwork. We shall need formwork. Remember, this part we have the wall. So we will not need formwork because we have the wall here. The place that we need the formwork for the landing. You see, as much as it comes into the wall, we will need, you see, the concrete comes up to the end here. So we need to support this part. And that one is from here up to here so that concrete doesn't pour outside. We shall support this side. Alright, then we have another wall here. In a staircase, when we go up here, we may not have a wall, but we have the balustrades here, the rails. They come this way. So this place which has some space, we have to support it using formwork. Alright, then this side we may not have constructed the wall. Here it's where we have the building, but this part most likely it's open, so we shall also support using formwork so that the concrete doesn't pour outside. When we get to that building where we have the staircase, we'll be able to show you quite clearly, but if you can relate, that could be so helpful. So we have said that we will need formwork for the soffits. First of all, soffits of the first flight, soffits of the landing, soffits of the second flight. Then we shall need formwork for the edges of the striggers when you're going up and when you're going up again. Then we shall need formwork for the edges of the landing, where we shall support this way, and here. So anywhere that concrete can pour. Alright, now we have the, by that we will have measured all the formwork. The next thing we need to take off is the concrete. For the concrete, how we shall measure the concrete, we shall take the concrete in the flight, the concrete in the landing, the concrete in the second flight. Now what you need to see is that the concrete in the flight is made up of, you see these steps. Once we draw a line from up here, it will come this way, it will come this way, it will come like this. Alright, so there are two shapes that we shall form. First of all, we shall form this rectangle. You see this one, this way, and this way. This is a rectangle that have been formed here. Alright? Then we have a set of triangles. This one is a triangle. This is a triangle. We want to find the volume of all this concrete that we shall use in this staircase. So when we are calculating the volume, we shall take the volumes by taking the areas of all these triangles. Alright? The areas of, even we can take the area of one triangle, we multiply by the length of the triangle, then we shall multiply. You see, this is the base area of a triangle, because we know that area of a triangle is equal to a half base height. So a half times base is the trend, which is 225, then times height, the height is 175, the height of a riser. A half times base times height, then we multiply by the length of the flight. That width of the flight is the length of this triangle. You see, this one is a section. We are seeing a triangle, but its length, it runs from here up to here. Alright? So we shall take the base area times the length, then we shall multiply by the number of triangles in this building. So even here, we shall come and draw a line so that we can separate the rectangle from the triangle, so that we can be able to calculate the total number of triangles. So we shall take number of triangles equals 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 triangles on the first flight. The second, for the second flight, you see this one is another one. So the second flight, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, so there we have 11 triangles. With the area of one triangle is a half times trend times riser. Then we multiply by the width. That one shall give us all the concrete that shall be in the steps. Now we want to know the volume of concrete that shall be in this waist. This part of the staircase is called the waist. Okay, and this one, to find the base area, we shall just take the length times the width. How shall we get the width? We are told that from the end here to here is the 50. And we have already been told that here, we had been shown in the drawing that this thickness is 120. If you are already told the thickness of the waist, you'll take the length from here up to here. Then we multiply by 120. Then you shall take the length from here. You see, this length is from here for the second flight up to here. Then we multiply by 120. Then you shall multiply by the length of the width of the flight. That shall give us the total span, which this one runs. Okay, so that one will give us the concrete for the flights. Now we want to know the concrete for the landing. What shall guide you to know the concrete for the landing is you start from here, where we have not accounted for the triangles. So from here, the dimensions from here up to the end of the wall, that is the width of the landing. This width we multiply by the length of the landing. Alright, so that one shall give us the area for the concrete. Then we shall multiply by the thickness to get the volume. The thickness is 175. So 175 millimeters. Once you multiply by the area, you shall get the volume of the concrete in the landing. Okay, so for the concrete, we shall need to take the concrete in the flight plus the concrete in the landing plus the concrete in the flight. We have said that the concrete of the flight is shown by two shapes: the triangles, which is the set steps, then the rectangle on the waist. So we shall take the volume of concrete in the steps separately, then the volume of concrete in the waist separately. Then we shall come to the concrete in the landing, whereby we shall take the width of the landing, which is not accounted for in the steps. Then we shall multiply it by the total length of the landing. Alright, so that one is how we shall take off the concrete. Alright, so when we shall come to taking off the reinforcements, what shall we do? We need to take off also the reinforcement in the flight, we take off the reinforcement in the landing, and we take off the reinforcement in the flight. So how do we go about it? For the flight, we have reinforcements that are running like this way. We need to calculate the length of each reinforcement. First of all, we shall need to know, you see, when we are going up a staircase, there is that reinforcement that is coming from this floor, running through the flight to the landing. Alright? So that reinforcement shall be looking like this. We shall have such reinforcements. We will need to know the length of each reinforcement. The length here is the length of a bend. Alright? We usually have the formula for calculating the length of the bend. Then we shall take the length of this slope, which is this one that we found here. Alright? So we shall take this length plus a bend to get the total length of each reinforcement. Then we need to know how many reinforcements we have. So what shall guide us is the drawings. We shall see what we are told. Maybe we are told these reinforcement bars, there were 12 bars with a spacing of 200. If we are told like that, and we know how to calculate the number of reinforcements, we shall take the width of the landing when we are going up. We deduct a concrete cover at the end, we deduct the concrete cover at the end. Then from one reinforcement to another, we shall find that distance. Then we shall divide by spacing plus 1. We have done taking off reinforcements. And we shall do, when we shall be doing an example of this staircase, you shall be able to see clearly. And also check out the videos you have already done. You shall be able to see very clearly. So, to find the number of these bars, you shall take the width of the landing, you deduct the concrete covers, then you divide by the spacing plus 1. Then you shall say how many bars, then the length of each bar. Alright? So, and there are those reinforcements running like that. These ones we shall see. There are these reinforcements that we shall only see the ends. Those reinforcement bars, we have been told they are 10 millimeters diameter and there are 2 at every step. To determine the number of those, we shall just count the number of steps. How many steps we have, then we multiply by 2 bars. Alright? And to get the length of each bar, those bars are usually like this. You'll just take the width of the landing, the width of the flight, you deduct the covers, both sides, assuming the width of the landing, like here, it's 1200. You deduct the covers, 25 on each side. Then you add the length of the bends. We have a formula for calculating the length of the bends. Maybe you're using 5.5D. Then you add this length of the bends to the length of this bar. So you'll get the total length of the bar. Then to get how many bars, you have already been told at every step there are 2. Alright, so if you come to the landing also, how do you know the number of bars? You will take the space that is in the landing. Then you'll divide by the spacing after you have deducted the covers plus 1. To get the reinforcement bars running across, you'll just take the length of this landing, you deduct the covers, divide by spacing plus 1. Alright, so the formula of finding the reinforcement is always the same. As long as you remember and keep in mind that you need to look at the diameter that you've given in the drawings, then you will take the total span where we have the reinforcements, you deduct the covers that you've given, then the spacing that we need to space the reinforcement bars, we divide by the spacing of the bars, then plus 1. Alright. So, when we come from the reinforcements, we need to know that in a staircase, we usually have other things like the balustrades. What are the balustrades? What are the rails? What are the standards? This reinforcement bar that is standing like this, and it's touching the step, and it's touching the top rail. You see, this is called a top rail. This rail that is on top. This one is called a bottom rail, okay? This reinforcement bar that is standing here, it's called a standard, the one that touches the step. So we have how many standards? We have 1, we have 2, we have 3, we have 4, 5, 6. Then in a staircase, once you have gone up, assuming you have gone up here and we don't have another flight going, we shall close. Assuming it's 1-story building, you need to check in the drawing whether you're told it's a 1-story building or it's a continuous story building. So if it's a 1-story building and we have rails here, Once we come up, we have to close this area using rails so that children will not fall off, or for security of everyone who is using the building. So we shall also have another standard here if we have been having standards supporting the rails. Alright, so these are vertical bars that are supporting the staircase and are touching the steps are called the standards. Then we have the balustrades. Balustrades are these vertical rails, but they are not touching the steps. They are connecting the top rail and the bottom rail. Okay. Then we have the rails. The rails we have said they have the top rail and the bottom rail. We need to calculate for all of these ones. We know the length so that you can know the length of these ones and how many are they. So that when you are going to buy these what are they called? These bars that are needed to fabricate them, we can be able to know the total length. Alright, so then we need to take off how many holes we shall do on the floor. You know, we shall pay for that. So we should be able to count the number of holes that we shall do on the floor so that they can fit onto the standards. Alright, so the next thing we shall come to take off is the finishes. We shall see, for example, we are told 25 millimeters thick terrazzo. We need to find the areas of this terrazzo. It's on the landing, the area of the landing that we can do terrazzo on. The area of the steps, the surface areas on the steps that we can do terrazzo on. Alright, so we shall count all that using the drawing. We have to refer to the drawing so that we can be told the areas that terrazzo will be done. The next thing we shall do the non-slip inserts. In every step, we shall have a non-slip insert so that we don't slide from one step to another when you are going down a staircase. So we need to know the number of these non-slip inserts that we shall use. Then plaster. Plaster is usually done to the soffit. The bottom parts are not left like that. They are done plastering. Alright? Then we shall finish with painting. We usually paint the rails, the bottom rails, the standards, we usually paint. Then we usually paint everywhere we have the plaster. Alright? So we shall use the drawing so that we can be able to know the areas of the plaster. So check out for the next video where we shall be able to do the calculation for this staircase works. Slowly by slowly. So check out the two videos for the staircase that we have done. I'll link them in the description box so that they can help you as you take off this staircase work. In case you have any questions, just write them in the comment section. We'll be able to assist you. Thanks a lot for watching. See you in the next video.